We were really keen with rural broadband to start exploring how you can deliver a better service and solution to remote places. There's been all sorts of challenges through conventional fibre, through 4G, and there are still areas with a lack of connectivity. And so could 5G, in its broadest sense of the definition, start to unlock a delivery to areas that have traditionally struggled? So our methodology was quite simple. Start with looking at the shared spectrum home broadband service, see if we can build off existing capacity to reach those destinations, as highlighted by the pictures, that sit nestled in the most difficult locations to get any form of connectivity to. I mean, in many ways, it was kind of a fool's errand because they are traditionally the most difficult tasks to undertake. But the team did some really interesting work, and they'll talk about that in more detail shortly. And we needed to monitor the performance of those deployments to see, did the activity live up to the manufacturer's hype? Can you deploy solutions that have been developed in other countries and elsewhere in the world? Are they going to work in a UK setting? If you look at the pictures, we have quite a lot of rain and quite a lot of trees. Notoriously bad combinations for radio signal. So could we use new technologies to allow us to reach those hard-to-reach places that couldn't be achieved before? I'm not going to steal their thunder, but I think we've done a really good job in starting to address those challenges. And today's a really good opportunity to tap into and ask questions of the team around what they thought, how they overcame some of the difficulties, and potentially to come up with the new ideas that Daniel suggested on the postcards, because we don't know it all yet. We're very much at the start of a journey, and we're looking to see how we can take it forward from there. So following on from me, I've got Steve and Alasdair coming up from Quickline, who are the lead partner on the 5G RIC consortium.
Okay, so good afternoon, everybody. We, as lead commercial partner in the process, we decided to split our approach into three sections. We decided to take the initial investigatory approach to look at technologies and identify areas where these, as Colin referred to earlier, where these could best fit. So we have a number of commercial customers already who are on a limited service with us. And we decided that we will want to look at the differing technologies under the 5G banner, see if any of those could be deployed to improve their sort of quality of service into those areas. So we looked again, like I said, to look to TV white space and to some 60 gigahertz technology. And we've applied those into areas where we had traditional challenges. Obviously, we had a lot of lessons learned throughout that process in terms of third parties and interacting with. But ultimately, I think we've had a lot of lessons learned, a few successes that we'd like to shout about, which we'll come on to later on. And ultimately, we've had some failures. But in those failures, we've managed to document why they were failures. And hopefully, that will benefit other people who step into our shoes later on down the line. So what I'd like to do is pass this across to Alasdair now. And Alasdair's going to have an overview in terms of what we've done, in terms of the technologies that we've deployed and those successes that we've had.
Hi guys, my name's Alasdair from Quickline. So we've worked on a number of different projects, but there's two that I'm going to talk about real quick. The first one is a TV white space project that we tried between two sites that we called Long Hills and Bardney. It's roughly a 13-kilometre link. It was non-line of sight, and it was in a high noise environment that was not far from TV transmitters. It suffered from really high levels of interference, and the antennas that we had available to us at the time seemed to have poor isolation between the polarities. So even when we were using alternate polarities different to TV, we were still getting tons of noise, and it prohibited the link functioning well. So we really struggled to get good levels of service. We managed to get about 30 megabits per second across that link in a completely non-line of sight environment, but when you put a number of users on the end of that link, it's just not enough bandwidth. So we deemed it not viable for that sort of application. We do have future applications which we're going to be trying. So we've got a non-line of sight link. We have a customer that's currently connected with 5 gigahertz behind a tree line. They're currently able to get a 10 meg service on the traditional services. So we're going to deploy TV white space to them, and we're going to see how fast we can make it go. We're looking for 30 to 50 megabits per second to this user on this next test, but we don't actually know what we're going to be able to achieve yet. The next project that we worked on was our Ingamells testbed. we have a service already existing in the Ingermells area, but it's basically saturated. So we were unable to deliver consistently good performance to all the users. It was suffering from really high levels of contention, and the whole thing needed an overhaul. So it seemed like a brilliant place to try and deploy a 5G network, leverage new technologies and see what difference it can really make. So one of the things that's interesting is it's a high-density caravan area. There's roughly 20,000 caravans. This is an example of a Ingermells. So where you see the pins are where we've put transmitter sites. What you can see with the picture of the caravan is a typical 5G installation in the Ingermells area. So this area, it's difficult to see on the picture there, but there's roughly about 20,000 caravans in the area. One of the things that's interesting is caravan usage isn't what I would have typically thought caravan usage was before I began this project. People are taking smart TVs in there, they're taking Xboxes, PlayStations, iPads, everyone's streaming Netflix, the kids are on YouTube, people are playing games. They're taking their homes on holiday with them, essentially. And the demand for bandwidth is actually quite high. So our legacy network was delivering 10 megabit per second services, but it was struggling at peak times due to contention. So we deployed a 5G network using 60 gigahertz radios in the area. The network we designed there, it's a fault-tolerant network that's self-healing. It's a high-density network, and it leverages 60 gigahertz spectrum. It's using back-to-back frequency reuse. We've built the network with a small cell design, averaging less than 700 meters between sites to maximize the density, and test real-world interference and co-location. So we've got, in the area, roughly 80 access point and backhaul radios. All the access points are using only 2 channels, and all the backhauls are only using 2 channels. And it seems to be operating completely interference-free without any performance hits. So we can test from any single points on the network to any remote locations and get gigabit speeds across all of it really well. Going forwards, based on what we've seen, I wouldn't hesitate to design smaller cells. So we went for like 700 meters between sites because I considered that quite high density. But going forwards, I think I'd be happy to go at half that distance. One of the things about 60 gigahertz is it's attenuated by air and water. So that actually allows you can leverage that to build much higher density networks and do much more than you think. It's really good.
Looking forward in terms of our phase 3, which was a slide earlier, we sort of look at this deployment as a technology template, and we would be looking to deploy this as a commercial solution into other rural area networks that have not been particularly well served historically. So going forward, we'll continue to deploy client access points throughout the area and get to a point where we understand what the saturation levels are, and then we'll obviously do a little bit of maths and try and work out what's the optimum deployment ratios.